Today's episode is proudly sponsored by the Rising Tide Mastermind. The term mastermind was originally written in Napoleon Hill's book, Think and Grow Rich. Before that, the earliest documentation that we have of a mastermind group was Ben Franklin's group that he used to meet every single week in a tavern that he called Huntus. Nation, there's no doubt about it. Life is too short to do it alone, and it's not very much fun to do it alone in. Nation, I urge you to go to scalinguph2o.com and find out if the Rising Tide Mastermind is right for you. I'd love to have a 15-minute call with you to explain all things Rising Tide Mastermind and see if this is a group that's right for you and you are right for the group. Go to scalinguph2o.com/mastermind. Welcome to the Scaling Up H2O podcast, the podcast where we scale up on knowledge so we don't scale up our systems. My name is Trace Blackmore, the host of this awesome podcast, and I want to thank you for listening today. So many listeners are listening on a regular basis to not only build up their knowledge on industrial water treatment, but to feel as they are part of a community. And that community is the Scaling Up Nation. And folks, I have to say, when I started this podcast over 7 years ago, I hoped that a few people would listen to it. What I never imagined was the community that would come from the listeners of this podcast. And Scaling Up Nation, I am just so amazed every time I go to an event and I see so many people wearing their Scaling Up H2O buttons to symbolize that they listen to this podcast. And I see them meet with other people wearing Scaling Up H2O buttons, and they'll walk down exhibit halls together. They'll go to technical papers together. And I just think that that is so amazing because that's really what this industry is all about. Anybody can do water treatment, but why would you do it alone when you are able to do it with comrades, with friends, with people that you trust, with people that can help you with issues that you are experiencing? Well, all that's nice to say, but how do you start that conversation? And it's so cool when I go to these conferences. And if you're wondering where you get a Scaling Up H2O button, if you see me or any one of our great team members at a water conference, we are always giving out buttons. And then people will wear those buttons to future conferences so they can be identified as Scaling Up Nation members. And like I said, people will seek each other out and say, hey, I listened to that podcast too. What technical paper are you getting ready to go to? Or what training are you enrolled in? And that starts a conversation and ultimately a brand new friendship. That has just been beyond my wildest dreams when I started this podcast. So for all of you that are doing that and making the Scaling Up Nation what it is, I want to commend you and I want to urge you to keep that up because that brings a level of what we do in our industry. It brings it to a higher level where one, we're not doing it alone. Two, we're able to talk with other people about our day-to-day without having to tell people what it is that our day-to-day is. And we're able to have more fun. We're able to solve problems. We're able to process issues. So all of that to say, I just am so humbled that we have the Scaling Up Nation. So Scaling Up Nation, here is to you. Thank you for not only listening to this podcast, but creating a community and being part of something that carries out our mission, which is to raise the bar in the industrial water treatment industry, one water treater at a time. And I am so happy to say that we have tens of thousands of members of the Scaling Up Nation. You know, when I go to those conferences, a lot of people will tell me that they didn't even know that the conference we were at was coming up unless they listened to this podcast. And this is something we started a couple years ago. There's just so much information out there, and you are so busy driving from account to account, servicing accounts, talking to customers, doing all the things that you have to do in your job. How can you possibly keep up with all the conferences, with all the different trainings that are coming up so you can schedule it in your calendar? Well, that's where the great team of Scaling Up H2O came up with our events page, and that's scalinguph2o.com/events. Or you can go directly to navigating in the top menu and going over to events. But it has everything that we know of that pertains to our industry. So you can simply click and plan the entire year. In fact, we've got more than an entire year up there. A lot of people plan their conferences for years in advance, and that's up on our calendar. So here are a few things that you might want to attend. March 4th through 7th, the Membrane Technology Conference is taking place in West Palm Beach, Florida. So this is all about new directions in water and wastewater technologies dealing with membranes. This is hosted by the American Waterworks Association. And if you want more information about this, it of course will be on our events section of our website. Nation, this next one is something that I look forward to each and every year because I am personally involved. And what am I talking about? I'm talking about the Association of Water Technologies Technical Training Seminars. And of course, we do that twice a year. And all the courses that are available, we have an RO training, we have a sales training, we have a fundamentals and applications training, we have a technical training, we have a wastewater training, and there's even an ASSE 12,080 training. So there is something for everybody, and you've got two opportunities to take these, and maybe you take one of the courses on one, and then you take another one on the following one. So what are those dates? Well, the first date is March 6th through 9th. That's going to be in Frisco, Texas. And then we have another one, April 17th through 20th in Cleveland, Ohio. So go to our events page, and we're going to have all that information for you. We're going to make it very easy for you to figure out which course you want to sign up for. And folks, by all means, if you attend one or both of these, please make sure you come up and find me. I love meeting members of the Scaling Up Nation. And I'll even give you one of those buttons that we were talking about in the very beginning of this show. Well, what else is going on? We've got the Water Loss Conference in San Sebastian, Spain. So if you are over there, you want to check that out April 14th through 17th. And that is hosted by the International Water Association. We're going to have all the information about that conference on our events page. And then finally, this is a big conference. This is the American Boiler Manufacturers Association Boiler Technology Conference and Expo, taking place in Denver, Colorado, May 1st and 2nd. This is all things boilers, and this is an amazing show if you have never been. So if you want to check that out, we will have that and everything I mentioned, and even things I did not mention, on our events page. You can go there by scalinguph2o.com and navigating over to the events page. Nation, as always, we are looking to learn on this podcast, and our friend James McDonald helps us each and every week with that. So here's a brand new Drop by Drop with James.
Welcome to Drop by Drop with James, the podcast segment where we wonder, explore, think about, imagine, and learn industrial water treatment. You guessed it, drop by drop. Together. In today's episode, I have a useful little quote from the 2021 edition of the Consensus on Operating Practices for the Control of Feedwater and Boiler Water Chemistry in Industrial and Institutional Boilers. Catchy title. By the American Society of Mechanical Engineers, or ASTM. It says, where Where a choice is available, the reduction or removal of objectionable constituents by pretreatment external to the boiler is always preferable to and more reliable than management of these constituents within the boiler by internal chemical treatment, which involves boiler blowdown and chemical feed to the boiler system. Chew on that for a minute. Where a choice is available, the reduction or removal of objectionable constituents by pretreatment external to the boiler is always preferable to and more reliable than management of these constituents within the boiler by internal chemical treatment. As vital and important as internal chemical treatment is to a boiler, consider all the ways it could fail. Would you rather manage hardness in your boiler with internal chemical treatment or by using pretreatment such as a water softener? Think about the benefits of other pretreatment as well. I've always considered this one particular line within these guidelines to be a very powerful sentence. I've used it to help justify my pretreatment recommendations as third-party support for softeners, reverse osmosis, etc. I'm James McDonald, and I want to encourage you to be like water by forming bonds with those around you, dissolving new knowledge, and making worthy ripples, drop by drop.
Well, thank you, James. Nation, we mentioned the Membrane Technology Conference taking place March 4th through 7th in West Palm Beach, Florida. Well, what a good opportunity to invite a guest to talk about membrane technology. Here's that interview. My lab partner today is Chris Drover of ZwitterCo. Welcome, Chris.
Glad to be here.
Well, we are happy to have you on the Scaling Up H2O podcast, and I would love it if you would introduce yourself to the Scaling Up Nation.
Sure. So, as you said, my name's Chris Drover. I'm one of the co-founders and currently the CTO of ZwitterCo. I came out of forward osmosis before ZwitterCo, so I've been around the water and water technology industry for about 10 or 11 years now. And so mainly I focus on membranes and membrane technology, but I've touched a lot of different pieces of that. So, I think that's kind of a little bit of my journey, how I came into it. But we started ZwitterCo in 2018, and it's been a journey ever since.
What does your day-to-day look like?
So today, I'm very heavily involved with our R&D teams, right? So we're working on a lot of new membrane technology. And then I spend quite a bit of time on the business strategy, just as part of the founding team and the leadership team, and thinking about the markets that we see as attractive and where we think our technology can help make a difference. And I do spend some time, especially on those emerging market ideas where we're not really sure how the technology is going to fit super well, or maybe it needs to be adapted and used in a different way, because there's a lot of different ways that people are tackling these water challenges. So as a membrane technology provider, we supply the membranes, but we get pretty involved, especially in those kind of early exploration of how the membranes are going to be used, supporting our customers, supporting our partners, and thinking through the different ways that they might use it. So an example might be, in some cases, you might drop a membrane into an existing process to maybe improve the effluent or pre-concentrate the input. In other cases, you're taking out, maybe what was done before and replacing it entirely with a membrane system. So I spend quite a bit of time on the target applications where we're trying to understand what attributes of our technology can help with that problem we're trying to solve, because it takes a lot of deep understanding of exactly what makes it tick to think of different ways you might use it.
Well, let's start our conversation with talking about wastewater. So if someone were to call you and they said that they wanted to deploy some of the technologies that you have in their wastewater operation, what are some of the questions that you're going to be asking from them, and how would you decide that you do have something that would improve their operation?
Yeah, that's a great question. So in almost every case, the first thing we're trying to understand is, how do you deal with this today? What are you doing today? And so we've seen everything from, they've got a treatment system, maybe it's a different kind of a membrane, or maybe they're using a biological system. We've seen we discharge it. We've seen we haul it away, because we can't treat it and we don't know what else to do with it. So we always try to ground ourselves, especially when it's a plant that already exists, with what's happening right now. Usually after that, we try to understand what's their end goal. It might be that they need more, they want to reuse some of that water for expansion, or they're really struggling meeting their permit requirements, or just the costs are too high. Whatever they're doing right now is too expensive. And then finally, we try to understand, have you tried anything else? And so what some of the things we look for is, maybe someone tried a membrane technology before and they had a lot of problems with fouling or cleaning. Or, they tried another technology and the water quality just wasn't quite there and they couldn't, reach the levels they wanted. So those are some of the clues that we look for that says, hey, this might be the right answer for them. Usually if the answers to those questions are, we have a conventional water treatment system, it runs well, we meet our effluent goals, and the costs are in check, it's less likely that we have a really compelling solution for them.
What are some of the traditional issues that you run into when you're using membranes?
So for a long time, membranes have been expanding in the market very quickly, right? So there's just been membrane growth has been outstripping a lot of other technology for many years because it offers a lot of really nice advantages when you're treating water and wastewater. As people have pushed membranes into, let's call it unconventional applications, where you're taking maybe untreated effluent from a factory, or you're trying to treat something that looks a lot more like industrial waste than, say, municipal waste, you run into this problem of fouling. And so what fouling is anybody that's sort of used a filter has gone through that experience of like the pressure on the filter is going up, the flow is going down. And it's a little bit different for a membrane because they're run in what's called a tangential flow mode. And so you have already some of the fluid is going through the membrane and some is passing out as concentrate. But it's sort of the same idea. All these organic molecules, all these oils and proteins and the stuff that you're removing from the water impacts on the surface and increases the pressure, reduces the flow. And so we really think about that as two different phenomena that are going on. And one of them is kind of, you can deal with it operationally, and that's the formation of this kind of film on the surface. And you go through different ways of cleaning that off. And some technologies use backflushing and some use chemical cleaning. But what a lot of people have experienced in these wastewaters is an irreversible loss of performance. And that's usually attributed to all these, fine organic molecules and oils accumulating within the little microscopic holes in the membrane and getting lodged in there. And they're very hard to displace once they're embedded. So that's been one of the sort of Achilles heels, if you will, of putting membranes into more and more heavily contaminated wastewater is keeping them performing for long enough to recoup the investment. And that's where we think our technology, is really a step change and makes a big difference. And that's what our market focus is unconventional waters that have a lot of challenges with fouling of membranes.
Well, let's talk about your company name and what exactly a Zwitterion is.
Yeah, that's a great question. So exactly, we're named after Zwitterions, and so Zwitterions came out of some research in Germany, right? Or earlier on in chemistry, and chemists started to identify types of molecules that seemed, they were very confusing at first, and this is kind of before the era of our modern chemical instruments. But they exhibited all the chemical behaviors you'd expect from a salt. So they seem to react to electric fields. They're ionized. They really seem like they're an ion. But they know, because they synthesized it, that they are in fact organic molecules. And they furthermore showed evidence of having both positive and negative charges. And so what a Zwitterion is exactly that. It's an organic molecule that has a part of the molecule, a specific, cluster of atoms, a functional group that's fully ionized and is a cation, a positive ion, and then another part of it that's anionic and that's a full negative ion. And so there are natural examples of this. Some of the amino acids fall in this category. Some of them are permanently zwitterionic, which means they exhibit that Zwitterion trait across the whole pH range, and some of them only show this property in certain pH ranges. So what's really interesting about this chemistry is it's kind of this almost like, the Venn diagram of, on one hand, you have inorganic salts and they're electrolytes, and they, we know what to expect. They increase the conductivity of water. They react to electric fields. They're very hydrophilic. And then you have organic molecules that are traditionally, more hydrophobic, and don't react to all these phenomena. And Zwitterions are right in the middle. And so you have these organic molecules, and we can do things like polymerize them, and we can use a lot of the synthetic chemistry techniques to manipulate them into materials. But they are also permanently ionized, and that means they're incredibly hydrophilic. And so that means water is really attracted to those ion groups and very strongly solvates them. And this means that when you make materials out of Zwitterions, they tend to really attract water molecules, really at the molecular level. And the corollary to that is that oil and other inorganics actually have, other organics have a really hard time sticking to them and absorbing to them because they're just soaking up water so quickly. And so we named the company after this because all of our core IP derives from how to build membranes out of Zwitterions. And there's a lot that goes into it. It sounds great. You're like, oh, we're going to make this membrane out of this really hydrophilic material. And people tried it, even 10, 15 years ago. The problem with really hydrophilic materials is they dissolve in water. So you have to get a little bit sharper on your chemistry approach to actually make a durable surface out of something that is that strongly solvated by water.
So you obviously found a way to combine the Zwitterion technology with the membrane. What does that do to the membrane?
Yeah, and I don't want to take too much of the credit for that. So, we have a strong relationship with Tufts University, which some research groups there did a lot of the early foundational work on this and developed the core IP. And so, myself and the other co-founders all have connections to Tufts, and we licensed that IP to form the company. But I don't want to certainly deny credit to the very talented researchers that did the foundational work on this. What this does for membranes is by building these membranes out of Zwitterionic materials, we can give them this really hydrophilic property that makes them virtually immune to that second fouling we talked about earlier, which is that idea of that permanent absorption of oil and organics into the pores of a membrane. One of the analogies I like to use to help people kind of visualize this, people think of a membrane almost like a pasta strainer, like this plane with holes in it. And that's actually the wrong way to picture it. A membrane looks a lot more like a kitchen sponge, right? So it's got 3D structure, and it's like there's a lot of pores in it as you move through the material. And I think if anybody has ever dipped a sponge in, grease and then tried to get all the grease out of the sponge, you've got a really good idea of what's happening at the microscopic level when you have membrane fouling. So our membranes are built a bit differently. They use the Zwitterionic chemistry, and the Zwitterions are just really, really resistant to absorbing any of that oil or grease material. And that allows them to be really easily cleaned, even under, really harsh upset conditions where, normally you'd be thinking about buying new membranes at that point.
In a typical RO, you look for a change in pressure across the membrane in order to know when you're going to clean it. Is that the same thing that you're doing with these membranes? How do you know when they need to be cleaned? And then a follow-up question is, what do you clean them with?
Yeah, no, that's a great question. So that was kind of our first thought. When we first started trying to see what the technology could do, we certainly started from what had been done before. Through a lot of our early testing with our customers, we realized a couple things. The first was that those usual cutoffs of, hey, you're going to, once your pressure increases 10% or so, you're going to clean. We can actually be a lot more flexible because we're not worried about, usually with a conventional RO or conventional membrane, there's a fear that if you let that build up too far, you're not going to be able to reverse it. And we just don't have that problem. We've experimented with letting the pressures go up by a factor of 10 before we clean, sort of simulating a really bad upset, and you could still clean them back to their starting performance. What we clean with, obviously it varies a little bit industry to industry, but one of the themes is it's generally much more mild and much cheaper to pull off. So a really common cleaning regimen for us would be a 50 part per million bleach solution that we raise the pH up to 11 or so. And you can clean without an ambient temperature. You just kind of recirculate it over the membranes, 30 minutes, and you should be back to your starting performance. In cases where you have specialty contaminants, like if there's a lot of iron in the water and you might end up with some citric acid or something. So you can use a lot of the usual, knowledge that's been accumulated in the industry about how to clean membranes. But we also have cases where customers water flush their membranes every day and they haven't cleaned in months. So, I'll give the usual water industry answer of it depends.
It depends. I'm familiar with that.
Yeah, and part of it reflects, we've treated an enormous variety. We got a project we're working on right now that looks a lot, it's a 20 ppm COD, 10 ppm TSS, and that's a really high flux application where we're just water rinsing to clean. And on the other end, we've treated fluids that, the concentrate is approaching 10% oil and grease. And so that's a different ballpark for your cleaning regimen.
So typically in a normal membrane situation, we're looking out for fats, oils, and greases, biological contamination, maybe high chlorine coming in from the city water. How does your technology change how we look at those things?
Yeah. So, it's important to think about what our technology removes and what it doesn't, right? So it's not an RO technology, at least not our first product, the superfiltration that we have out on the market. What it excels at is removing oil and grease, organic biopolymers, algae, viruses, bacteria. So it really sits down at the very tight end of ultrafiltration, if you think about the conventional technologies. Now, in terms of how you think about, the issues that you usually see with membranes, we really have no problem with oil and grease. We've done a couple of projects for, food oil companies that have like emulsions with a couple percent oil in the water, and we can do water extraction from those without a problem. The chemistry is chlorine tolerant, so we use bleach to clean. We no concern if there's bleach in the water. Obviously, if you're going to go on to another stage, and we see a lot of use cases where people are using our membranes to provide pretreatment, and then they're going to polishing for RO if they want to reuse the water. At that point, you're going to have to deal with the chlorine, of course, before it goes to an RO. But you have a lot of options in terms of, when you're looking at just that kind of primary first stage of filtration. Mainly, we think about solids, honestly. It is still a membrane. They're spiral wound. They're not going to do great if you let feathers and macroscopic objects, try to flow through them. So most of our pretreatment concerns are in things like, can we make sure that we've excluded larger solids that are going to impinge, within the tight clearances in the module?
Can you tell us some field studies that you've had experience with?
Yeah. So our earliest piloting work, which is, about 2.5 years ago now, one of the first markets that we went after was anaerobic digesters. And so these are, there's a lot of different types out there. And the ones that we focused on first are actually the manure digesters that are increasingly common in the Midwest. And so these are primarily processing exactly what you think, manure from cattle operations. And that's a tough fluid to deal with. So this is you're looking at the liquid fraction that comes out of the digester after the anaerobic digestion. You've got a lot of organics. You've got some fibrous material to deal with too. So it is a multi-stage process. The partner that we've been working with in that market does a kind of a screw press technology first to get all the fiber out. Then we go to the ZwitterCo membranes to provide that sort of primary organic concentration. And that goes to very high recovery. So these are, maximum water recovery operations. You're targeting usually north of 90% permeate recovery from those operations. And then in that case, they all then went on to RO. And the kind of cool thing about this process is there's opportunities to valorize the concentrates because there's a lot of nitrogen and phosphorus and nutrients in those concentrates. And so they have some early work going on with actually then selling that into the fertilizer market to help the cash flow of the operation. So when we started, our field studies on this, we were really focused on trying to learn about things like how often do we need to clean these? What kind of flux can we run at? Any other concerns like that. And we went through the usual, we tried one set of conditions, we tried another, we seemed to hone in on a solution that worked. And that's been one of our more active commercial markets. We have a number of those anaerobic digesters that are up and running at full scale with our technology at this point.
What are some other industries that you're in? And I'm curious, what are some of the specific issues that come with those industries?
Sure. So, landfills and landfill leachate has been a popular one. And I mean, obviously, you talk to any landfill operator with leachate right now, and kind of the number one issue they're dealing with is PFAS in a lot of that leachate water. So we have a couple installations with landfills. Again, these are multi-step trains with usually using the ZwitterCo superfiltration followed by RO to fully remove all the PFAS compounds, concentrate them. These are membrane technologies. They don't destroy PFAS. And so there are other technologies out there that are designed for that. But what a lot of them benefit from is concentration, right? So instead of treating 200,000 gallons a day through a supercritical water oxidation or an electrochemical process, you concentrate it down to maybe 20,000 gallons a day, and that's going to save a lot of capital on that capital-intensive destruction step. So that's kind of one issue, and we've got a couple commercial landfill installations running. Probably the biggest theme that we see in the market right now is actually just in the food supply, right? So protein production as a theme, right? So you look at this is meat, poultry, seafood. These are pretty water-intensive operations. And that wastewater has a lot of protein. It has a lot of concerns with salmonella and sort of, disease transmission. And what we've found, in the US and even abroad, is that the water issues for like a meat processor or even some of the newer like plant-based meats and some of the bioprocessed foods are becoming pretty strategic for those companies. So, a few decades ago, if you're a chicken producer, you're thinking about your strategic plan and you're going to plan for an expansion and you need to make sure you can get enough chickens and that sort of thing. Water usually wasn't on that list. But what we're seeing now more and more is that, when people are thinking about, okay, we're going to build new, meat processing or chicken processing or something, water is pretty near the top of the list on strategic concerns to deal with. I think, there's a public story out that Costco faced this. So Costco went and tried to vertically integrate and do their own broilers to keep that rotisserie broiler at the price point they wanted. And they ended up building, a wastewater treatment plant, basically, because there was no infrastructure available to deal with the wastewater that they needed to put in. So that's been a theme we see. We have a lot of work going on in different parts of that market right now, between poultry, between beef, seafood, aquaculture. These are all areas with a pretty high water intensity. And the water situation is often a sort of capacity limit for those plants. So they might have the space, they have the capital, they have the people to expand, but the infrastructure isn't there either to give them more fresh water or to deal with more wastewater discharge. And then obviously those are fairly consumer-facing brands, and there's a lot of brand value in kind of being a leader in water stewardship also.
What are some other ways that people are using your technology to increase their ability to keep the water within their facility so they don't have to bring on new water?
Yeah, so this is one of the themes that kind of led us to what's now launching as our second product, which is actually an RO technology, with the Zwitterion technology. And that's where we're seeing there was kind of a wave of people, put in a lot of industrial RO, both as, say, maybe treating the surface water or the well water to go into their process, and in many cases to try to reuse water in that plant. And so there was a big wave of that went in, and a lot of it works really well, and some of it's really struggling with organic fouling. And so that's where we're have just launched that technology and that product coming to market now, and the first commercial elements just shipped earlier this month. Within the effort to do water reuse, almost always that's going to lead through an RO membrane because people want that really pure quality. It's often going to lead through several other steps, and so we have both the sort of the superfiltration pretreatment that we can provide, especially like in a new construction, when they're putting in a process and maybe they haven't figured out how to make it work yet. But we're increasingly also seeing the wave of old, I don't want to say old, but existing plants that have maybe an RO for reuse in that are really struggling with uptime or with cleaning costs and things like that. And so sometimes these plants are facing the difficult decision: do we have to shut this down because this just isn't working? We're chewing through cleaning chemicals. So that's kind of one of the areas we see. One of the fascinating dilemmas with water reuse is, of course, it really starts to blur the lines between what's wastewater and what's water. And wastewater and water have practical definitions. They also have legal definitions. And so there is a lot of work that's being done to try to clarify these issues. And this really hits hard in food, where there's understandably some pretty tight regulation about what wastewater touches in a food plant, and a lot of confusion about when it goes from being wastewater to water and the circumstances under which that can be done. So we're working through that, very carefully with some very informed partners and government partners and industry partners. But one of the themes we see is that often the first step in that water reuse for a plant, rather than taking that reclaimed water and maybe going back into the food production process, they have all these other ancillary uses of water on the facility. They're watering the grounds, they're washing trucks, they're doing cleaning. And so often the first step in that sort of water reuse rollout is going to be taking used food processing water, creating recycled water, and then using that for non-food purposes, therefore drawing down, not using sort of precious freshwater supply for uses where you can really just use reused water.
Chris, earlier you mentioned it was hard to build membranes out of hydrophilic materials. Can you speak more on that?
Yeah, so there was an early wave of research in both Zwitterions and many other hydrophilic materials of, let's just try to put this onto an existing membrane, make it more hydrophilic. Think of it like a surface treatment. And there was a lot of research that came out, and in some cases it seemed to make a difference, but it would often wash away over time, or it would seem to help the rate, but not actually change the end result and the outcome. So what makes ZwitterCo's technology unique is at first we build that entire selective barrier, that kind of film with all the pores is made out of that zwitterionic material. And so, unlike a surface treatment where some fraction of the oil and grease is always going to get through your surface treatment and then it ends up clogged in your membrane, the whole membrane's made out of that surface treatment. So this is actually a pretty tough material science challenge. And, if any of your listeners are familiar with how membranes have been made traditionally, it kind of relies on using a lot of actually fairly common, basically plastics, things like nylon, things like polysulfone, PVDF, and then going through a manufacturing process to kind of coax that into being a porous material. And that entire process actually relies on the fact that when those contact water, they're gonna fall out of solution because they're fundamentally plastics. That's kind of how membrane casting works. To build a membrane that's so hydrophilic that it's immune to fouling, you have to approach the problem a different way, right? You can't rely on putting it in a solvent and dipping it in a water bath because it's gone. It's just going to dissolve in the water. So what ZwitterCo is founded on, and the really cool piece of the technology is you can think of it as combining this kind of one field of chemistry that's dealing with how can we make really hydrophilic materials. And then there's this other branch of chemistry on self-assembling materials. And so for a while, there was like a journal of self-assembling materials and a journal of hydrophilic materials, and this, what's cool about the technology is it really combines these into one technology platform. And so when we make our membranes, we are designing the materials they're made out of. I mean, we make our own chemistry. We have to synthesize all the stuff we make these membranes out of. And we can design those polymers and those materials to give them the properties we're looking for. And the specific property we want is that when we form it into this film, we want water to be able to pass through, right? That's the whole point. And so by combining these kind of two different fields of chemistry, we have these materials that do, when you sort of apply them under the right conditions, they self-assemble into a porous material, and those pore structures are made out of one of the most hydrophilic materials that we have access to. And so that's kind of what makes it really powerful. There's a lot more that goes into the chemistry because we have to stabilize it. We have to make sure it's, durable and chemical resistant and all the other properties we need, which is why we have to make our own chemistry. But we manufacture these in a fundamentally different way. Our manufacturing lines don't look like a conventional membrane manufacturing line because we're getting a lot of the performance that we want by the chemistry that we're starting with. And, you can contrast that with buying what's fundamentally a normal plastic and then having a process to kind of coax it into being a membrane. These materials are fundamentally membrane materials.
Chris, when we have experts on the show, there's normally that one piece of information that if everybody knew, it would make your job easier, it would make our job easier. What's that one thing you want everybody in the Scaling Up Nation to know about membranes?
That's a great question. When we look at where are the sectors in the market and what are the challenges people are trying to solve in those sectors, There's some low-hanging fruit. There's some obvious ones, and obviously the people that already realize this are like, of course. But, when you think about the different types of technology that are out there, and whether we're talking about membranes or other new technologies, you can kind of break most water treatment technologies down into things that do separation and things that do elimination. And there can be a surprising amount of confusion on that. So one consequence is just like RO or NF or UF, every membrane installation is you're going to have a concentrate, right? Everything we remove is going to end up in a much smaller volume. And, and our data shows we can usually achieve, some of the highest recovery rates that are available with membrane technology, but it's not 100%. And so, when we look at a lot of these plants and we start doing, trying to understand their water problems, occasionally we'll get kind of down that road and realize, oh, you need this to disappear. You don't need to separate it. And so that's kind of one angle that it's helpful for people to think about if they're thinking about say you've got a flow and you got, 500 ppm of BOD in it. We can concentrate that, right? We can give you clean water that's low in oil and grease, low in BOD, but all that pounds of material still got to go somewhere. And so it's helpful to think through when you're thinking about your water challenges. We can separate things, we can combine them, and there are technologies on the market. You can digest them, you can turn them into sludge, but everything that's coming out of that operation has got to have a home eventually.
If we were able to get into a time machine and go into the future, where do you see the membrane technology going?
So what we're working on, and the opportunities we see, there's a couple trends, I think, that through talking to our customers, we're starting to pick up on. I talked earlier about protein and food and the really strong connection between the food supply chain and water scarcity and water issues. And you can kind of go through the entire food chain and just spot water issue after water issue, especially as sort of agriculture and farming is going through intensification, trying to get more out of each acre, right? That's creating a lot of follow-on water issues that, of course, then get even more compounded by climate issues and drought and those sort of things. So we are, in terms of the technology focus, we're trying to understand where all those unmet needs are. I think that you're going to see MBR is a very powerful technology that's had a great rollout. And I of course personally think it's a fantastic technology that probably needs some better and better membrane materials that are more suited to handling these, really high suspended solids and high organic fractions. A lot of people have issues with like foaming in their MBRs, and then your options for anti-foam are limited by the membrane chemistry. So I would expect, if we had that time machine, there's probably a really nice new generation of MBR technology that is getting denser, is getting more compact, is getting more capital efficient. In desalination, of course, the progress in polyamide seawater desalination technology is just unbelievable. And so, you're probably not going to see a magic membrane comes out that just reduces the energy to do desalination. With fairly high certainty, that's not going to happen. But what you do see is people are trying to build desalination plants in less and less ideal areas. And so as countries and states are turning to desalination when they need to increase their fresh water supply, they don't always have the luxury of picking an area with really low algae potential and really low biofouling and really well-designed beach wells and all the great, techniques that have evolved to make those plants run at these incredible specific energy values. And, even getting into the politics, you see there's increasing pushback to like the really large scale 100 MGD, 200 MGD desal plants. So I think one of the places that you will see membrane technologies start to affect that is as you get more biofouling resistant materials, as you get more pretreatment options that are more modular, that scale down well, you start seeing these 20 MGD, 50 MGD plants that are built in really non-ideal locations that have issues with algae, that have issues with biofouling. You don't always have the luxury of building a mega plant at the perfect spot, on the ocean.
By the way, you have to trademark the term magic membrane.
Yeah, exactly. We'll make it, I promise.
That is marketing genius right there. Let me ask, if somebody wants to learn more about the products from your company, what should they do?
So, obviously we have a website, and I'm actually excited to say if you, depending on when this airs, we do have a new website coming out in a few weeks that'll have a lot more case studies, a lot more application data. We are also prepping to do a little bit of an unveiling of some of our innovation center here. So we've made some pretty large investments, both in our lab resources, but also in pilot manufacturing resources that we have at our disposal to bring new membranes to market. And as that website relaunches, there will be, I believe, a tour. It's probably a more like a December, January, but that'll be out there to learn more about our innovation process. Our team is really also active at a lot of the industry events. So we've got a bunch of people, even this week in Europe at Aquatech. We'll have folks giving case studies at all the major conferences, through the conference season.
And we'll make sure to have information on our show notes page as well to make it easy for people to find you. I got a couple of lightning round questions for you if you're ready for those.
Sure, let's do it.
All right, we spoke about a time machine before, so we're going to get back into that time machine. Go back to your very first day as a chemical engineer. What advice would you give yourself?
Oh, that's a tough one. I think, one of the things I wish I had thought more about earlier or known more about earlier is, when you're getting into the industry, it's you really need to put some thought into how you specialize, right? And so I didn't start my career in membranes, actually. I worked for a little while in material science, actually in the electric industry, and I did a lot of work with PCB contamination and insulating materials. And ironically, a lot of the chemistry lessons crossed over. We're wrapping wires in plastic films that have to keep water out. There's a lot of similarities, actually, in some of the work. But I think it's not always obvious how specialized some of these domains are. And, I think if you get the chance to talk to one of the membrane gurus, right, that can they're everywhere. I think every membrane company has got a couple that just know how to make a membrane. You don't learn that in school, right? You learn that by making membranes. And so, if you're a chemical engineer in the workforce, you got to realize that chemical engineering is a pretty broad endeavor, and you're gonna need to be thinking about those really specific skills that you're going to need to acquire that are not in textbooks. So that was something that wasn't obvious to me in the beginning. And fortunately, I found my way into it and had some great mentors and learned the trade. But I think, had I realized how critical those sort of industry specific skills are, it really just emphasizes choose with intention early and make sure that, you realize that as you go down one road and pick up a bunch of skills and you want to switch to a different type of field later, you're going to start over.
What are the last few books that you've read?
Well, I guess I'll start with on the fiction side. I mean, I guess we'll start there. I finally finished off. It was a Blue Mars, so the Kim Stanley Robinson trilogy, which took me a couple of years of fits and starts to go through all of them, but that was great to finish off. On the nonfiction side, there's a great book called The Nature of Technology. The author's name is escaping me at the moment, but I'm sure we'll get it in the show notes. And it's a really kind of fascinating story to kind of weave through different case studies of sort of how technology hits the market and then evolves and migrates and becomes what we know and see today. Because it's actually pretty common, when you get down to it, you think of sort of mass adopted technologies. Cell phones is a great example, the internet. They often look absolutely nothing like what people forecasted when they hit market. And so they go through this process that almost looks like evolution, in a biological sense. So that was a fascinating read.
What are some of your favorite membrane resources that you turn to?
Sure. So I will be a little cliched and say I have some fantastic people that are by far the best resource to go to there. And I mean that quite literally. There are some great membrane texts out. There are some wonderful journals, and there's been some great new journals that have come out, even with Journal of Membrane Science, but there's a couple other new ones and even open access ones that are out now. But ultimately, if you're in membranes, you're going to eventually meet one of these people that you say, can you make a 15K UF membrane? And it takes them like a day. And that's hard to write in a book.
When Hollywood makes a movie about your life, who do you want playing Chris Drover?
Oh, I would be so privileged. I will admit I am probably not up to speed on the current cadre of Hollywood stars to give a salient answer to it, but I'll just say I hope that they don't make me too eccentric, because I do have my moments of normalcy.
Well, if I get to take a stab at it, I would say Ed Norton.
I could live with that. I'm a product of the Fight Club era. Growing up with that as one of our sneak out of the house and go watch movies our parents didn't want us to.
You've already said too much about Fight Club.
Exactly.
My last question for you: if you could talk with anybody throughout history, who would it be with and why?
I would be absolutely fascinated to see the reaction of some of the earlier figures, especially in the Industrial Revolution. As people were, you always think about how would people in history react to the modern era. And reality is, for a lot of people through history, it was, probably some mix of shock and disbelief. But I think it would be really fascinating to talk to some of the late 19th century people engaged in science and industry, because I think they probably did have at that point the vision of hey, this is the future. And it would be fascinating to see, for some of the early folks that were really developing the field of chemical engineering, and mechanical engineering, that probably did think about what future technology would hold and or at least engaged in that and see what their thoughts are and find out, where are we ahead of pace or behind? And I think you'd find both. There was certainly an era when it was like, oh, year 2000, we're in flying cars, and that certainly didn't come to pass. But on the flip side, I don't know that a lot of people in that era conceived of the internet or large scale desalination and some of the things that are pretty easy to take for granted today.
Chris, I want to thank you for coming on this Scaling Up H2O podcast and educating us more about membranes.
Thank you. It's my pleasure.
Well, Nation, I am sure you have learned something from that interview. I know I did. And like I said, I remember a footnote in a chemistry book about Zwitterions, and maybe it had just been a term that was defined, but we did not go into it the way that Chris did today. So thank you, Chris, for coming on the Scaling Up H2O podcast, and thank you for bringing new technologies for us to consider how we're doing wastewater, how we're taking care of our customers. And I tell you, that is a hard word to say, Zwitterion. So with that, maybe you can say it better than I can. And now we all know what that is, and we all know what to look for. Nation, the other day, I was talking with somebody that was thanking me for recording some of our water treatment guests. And unfortunately, some of our water treatment guests are no longer with us. And last year was a big year for losing a lot of people that were very close to me in the industrial water treatment community. One that comes to mind is Rob Ferguson. And many of us know Rob Ferguson because he was the person behind WaterCycle. And WaterCycle, if you are creating a product for the water treatment community, Rob created this database so you could predict how your product was going to perform in different types of industrial water. And Rob was just so gracious with all the information that he had. I know I talked to him on more than one occasion. And Rob was one of those guys that just wanted to help everyone. I remember when I was just starting out, he told me I couldn't afford his software, but eventually I would be able to, and he gave me a copy. I mean, that's just amazing. That's the kind of guy he was. And here's the cool thing. I was able to record him. It was one of my earlier episodes. So maybe you want to hear from Rob Ferguson. Well, you can. That's going to be episode 43, and it's entitled The One with the WaterCycle Guy. Now, Rob had his own language when he spoke, but he was just such a wealth of knowledge on all things water treatment. So here's something that I want to encourage everybody to do. I hope everybody has a mentor, that's somebody that they can talk to help them get further in their water treatment career, in their water treatment knowledge, and just have a great relationship with. Eventually, we're going to have to give all the knowledge that we have in our head to somebody else so they can carry that and make that even greater. So my next challenge for you is to try to be a mentor for somebody else. Think of all the knowledge that you have inside your head, and why would you want to waste that? Why not share that with somebody? Because when you do that, you're improving the water treatment industry to whomever you're talking with, and you're having fun in the process. Here's the other thing that happens, though. When you share information with other people, you now get to know the information that you already know on a higher level. Because when you explain something to somebody, when you teach it to somebody, it's a totally different experience. And through those questions, it's going to allow you to examine the information that you already know in a different way to get you to know it in a different way. I just get excited thinking about that, because that's something that I like to do with any opportunity that I can get talking with somebody in this industry. That's why I teach with the Association of Water Technologies. That's why I do this podcast. That's why I do coaching. It's because it allows me to get information out. It allows me to gain a lot more information, even information that I already think I know. I get to know it in a totally better and different way. So Nation, I hope you take it from me, and I hope you take advantage of that. I also hope that you tune in to a brand new episode next Friday. Until then, have a great week, folks. Do you wish you had your own private tutor to help you study for the Certified Water Technologist examination? Well, now you do. So many of you have asked me to help you with the mock CWT examination, and I've done that very thing. If you go to scalinguph2o.com/CWT prep, again, that's scalinguph2o.com/CWT prep, you will see that I've created a course, and I tell you everything I know about each one of those mock questions. It's my hope that that helps give you the confidence you need to sign up to get certified today.